drilling fluid is actually the lifeblood of the HDD. So if you don't have the right combination of mixture, if you don't have the right combination of volume, your job site can come to a halt pretty quickly.
Hello everybody, this is Mike Kezdi, Managing Editor of Trenchless Technology and Trenchless Technology Canada magazines. I'm excited to bring you today's episode of the Trenchless Technology Videocast. Today I sit down with John Cope, Applications Engineer at Vermeer Corporation. We chat about all things fluid management and some new fluid management equipment coming down the pipeline from Vermeer. We hope you enjoy today's show. Well, thank you, John, for joining us today on the Trenchless Technology Videocast. Can you tell our viewers just a little bit about yourself, your role at Vermeer?
Yeah, sure. So I joined Vermeer almost 11 years ago. And so my role is reclaimers, helping develop new reclaimers, prototyping reclaimers, also training our dealership and customers on how to use the reclaimers, also high pressure pumps. So that's what my main focus is with Vermeer, is reclaimers in the high pressure pumps.
Great. Well, I know that you mentioned you joined Vermeer 11 years ago, but your history in the industry goes back longer than that. So why don't you tell us a little bit about your overall career and what have you seen change, and kind of what innovations you've seen come along the way in the work that you do?
Yeah, so I live in Houston, Texas, and my career started off in the oil field, of course. I started out with the electrical work, both onshore, offshore, and that kind of progressed into solids control equipment. I worked for another manufacturer that we built solids control equipment for the HDD environment as well as the oil field. Some of the innovations I've seen with the HDD environment, HDD industry coming up, is, when I started, 400 gallons a minute was, that's what we need. That's all we need. And over the last 25 years or 30 years, it's progressed up to where I need 800 gallons a minute. So those things have progressed. Also dumping. I mean, it's got so environmentally friendly and restrictive now. We used to be able to dump in different locations, but that's now been regulated. So our industry has changed a lot.
Now, you've seen these industry changes, and I know that Vermeer has been part of the industry for a long time. Can you share with us, their place in the HD market, how long they've been there, and the fluid management side specifically?
Well, Vermeer has always been an innovator in the HDD market. So whenever they got their start, way back when, building their first drills is whenever fluid started coming around. Maybe way back in the old days, you didn't really have a mixed system as we have today. They've progressed also as far as the size of drills. Incrementally, they've been going up every year with Vermeer. And so now we don't not only offer the small 9x12s, but we also offer everything up to 1 million pound.
Since your focus is on the fluid management side of the HDD industry, can you kind of explain to people, to help them understand better the importance of fluid management on an HDD job site? Keep in mind that some people might not be as familiar with the technologies available.
Right. So fluid management not only encompasses recycling, but you also have to look at, how do I get my fluid from side to side? How do I dispose of any of the fluid that I need to dispose of? How do I get rid of my spoils? How do I bring in fresh water? My mix system, how long do I have to mix my mud in order for it to be at its full potential? So all those encompasses, basically fluid management, what I do with all my fluid at the end of the job. So there's a lot to do with fluid management. Some of it is thought about before the job starts. We have some people that are reactive, which we try to encourage them to be proactive. Know your volumes, know your soil conditions, and then have a contingency for inadvertent returns. So one of the things that I'll always say is, drilling fluid is actually the lifeblood of the HDD. So if you don't have the right combination of mixture, if you don't have the right combination of volume, your job site can come to a halt pretty quickly. And we also have to look at the other end of it. Okay, I've got the right fluid, I got the right volumes, and you're going to create quite a bit of volumes depending on what size drill you have. But what do I do with that fluid at the end of my job site, or how do I manage it during the job site? I'm reaming and I'm having to transport fluid from one end of the bore path to the other end of the bore path. I'm having to bring in fresh water to mix new mud. So those are all aspects that come into how to manage my fluid on my job site.
Yeah. You mentioned it, and I've heard many people mention it in the past too, that, drilling fluid is the lifeblood of the HDD process. So how important is the proper mud mixture, and how does it affect the efficiency of an HDD job site?
So without the proper fluid mixtures, you could have inadvertent returns, which is very costly. I could also have slow penetration rates, which slow down the price per foot, which would slow down the price per foot. I could also have basically my hole collapse on me because my fluid is not able to sustain the bore path. So the fluid is meant to cool the bit. It is also meant to evacuate the cuttings or suspend the cuttings out of the bore path. It's meant to make a filter cake to keep the bore path opened up.
Now, I know that some HDD contractors use a reclaimer for their excess mud. Can you explain what a reclaimer is and its role on the job site?
So whenever we look at a reclaimer, we're not only looking at the excess mud that has happened to be used on the job site, but what a reclaimer allows you to do is use that fluid in a closed loop situation. So whenever I'm using the fluid, I'm recycling that fluid and then I'm supplying it back to the drill. So at the end of the job site, whenever you start pulling pipe, that's when you'll have excess fluid and you'll recycle that fluid and you'll be able to dispose of that fluid a lot more efficiently because I'm just disposing of that fluid in particular and not the solids that go with it. So how does a recycler work? So a recycler normally will have a mix system, or there's a mix system on the recycler. You'll add your bentonite and your polymers or whatever your soil conditions suggest for that formation, and then you'll send it over to a high pressure pump. There's normally a charge pump on the unit. You'll send it to the high pressure pump. The high pressure pump will then send it down to the drill stream, and then it'll exit either turn the mud motor or also exit the bit. So you're cooling the bit, you're adding lubrication to the bore path, and then you're carrying out the cuttings. So as those cuttings come back out of the bore path, we'll have a pit pump there to pick them up. That pit pump will transport that drilling fluid laden with cuttings over to the first stage, which is the scalping shaker. So the scalping shaker will take out the bigger particles, the large grain sands, the gravel, the rock, the roots, whatever happens to be fairly large. We would say probably somewhere over 100 microns. And then that'll go to the next stage. And the smaller systems, we just have desilters. In our larger systems, we'll have desilters, desanders, and desilters. So it's a 3-stage system. So normally in our mid to small drills, we only have a 2-stage system, which is the scalper, and the desilter. So once that fluid goes through the first scalping shaker, it'll end up in the scalp tank. Pump will pump that fluid up, go through the hydrocyclones, again, whether it being desanders or desilters. The cyclonic effect will separate the larger particles from the usable drilling fluid. That fluid will then go back into another tank. And what we like to do is we like to be able to transfer this fluid at least twice. So if we are using 400 gallons a minute, we want to be able to have our recycler recycle at least 800 or process 800 gallons a minute. So that goes through the gamut of our different sizes of recyclers, our R250C or R600. So if we want to be able to recycle 600 gallons a minute, we have to process 1,200 gallons a minute. And we have a new product coming out. It's the R125, and that's going to actually process that fluid 3 times before it's transferred back to the drill. Again, back to the scenario. So the underflow from the hydrocyclones will then go across another deck, and it'll be dewatered. The clean fluid will go into the clean side tank. That clean side fluid will be then transferred back to the high pressure pump. So it's a closed loop system.
Great. So you mentioned the R125 there. Can you talk to me about the Vermeer lineup of reclaimers?
So we try to size our reclaimers according to, again, certain drills have certain capabilities of mud pumps and also capabilities of hole opening. So we want to be able to size a reclaimer for the drills that we do produce. Our R125 will take the smaller class of drills, or what we call our core drills. And that'll be from the D24 up to the D60 by 90. And then the next stage up would be our R250C, which is running the 100 by 140 class. And then we have our largest reclaimer, that's R600, will handle up to our 330 and beyond.
Now you have this range of reclaimers based on the drill sizes. Can you talk a little bit about the overall impact that a reclaimer has on the HD job site?
Yeah, so what a reclaimer is going to do is, if I just was to use that fluid one time, especially in our smaller drills, whenever you get into the larger class, the R250Cs and the R600, it's a given. I mean, you're using 300, 400, 500 gallons a minute. It adds up really quickly. You have to recycle that fluid. Now, whenever you look at our core drill class, sometimes they're using 10, 15 gallons a minute only. So that doesn't add up to a whole bunch if I don't have like a strange predicament or an expenditure that is unforeseen or not is planned for, but it takes a long time in order to accomplish that. That could be, it takes a long time for me to get to the dump to be able to offload my used drilling fluid, or it takes me a long time to get water to my job site. If any of those parameters are not within range, then that's going to cause me to have to actually slow my drill site down. And it's also going to cost me money because I'm waiting on something. The driller's having to wait for the water to come back, or he's having to wait for the vac to come back because my pit is filling up full of spoils. And so that's kind of where we look at it. If I'm only using 8 gallons a minute and my disposal site is 2 minutes or 3 minutes down the road, and I'm getting water from my fire hydrant, well, it may not be economically viable for a reclaimer to be on a job site. But by using, if one of those parameters are off, for instance, it takes me an hour and a half to go to the dump to dispose of my used drilling fluid, and it costs me, $200 or $300 for a 600-gallon vac. That may be a parameter where a recycler will come in very handy, and it'll be cost efficient for the contractor. Again, I was on a job site and it took an hour and a half one way because the actual vac had to go out. It was on Air Force Base. The vac had to go outside the Air Force Base, dump their fluid, and then they had to go back through, which meant they had to go back through inspection. So that was hour and a half out, but 2 hours back. I was also on another job site in New Mexico where water availability was way out there. They had to go an hour and 20 minutes to go get water. And of course, it took them 30 or 40 minutes to get filled up and then the return trip. So if any of those parameters are out, even using only 10 or 15 gallons a minute, those numbers come in back into the equation really quickly.
Yeah, well, obviously this discussion with you really highlighted the importance of fluid management reclaimers on an HDD job site. I certainly learned, something new in today's conversation. You mentioned the R125. Does Vermeer have anything else new coming in the way of fluid management?
That's our newest product coming out. It's been released. It will be released to the public here after customer days next week. So it's been on our website, but public launch will be next month. So in the R125 class, even what we're looking at too is for our core drills. So if our penetration rate is very slow, it's like a half a foot a minute or so, and I may only get 5 rods or 4 rods in a day. Well, those numbers come in line real quick because I'm using that fluid over and over. I don't have to sit there and dispose of it. I can reuse the recycler in a closed loop system. I can use my mix systems in order to replenish some of the fluid that I'm encountering in my fluid loss. So yes, our R125, we had a gap in our reclaiming system, and that's going to be filling our gap now.
Great. Well, that kind of wraps up today's brief conversation. As I said, I learned something new in this chat, so I appreciate you taking your time today to chat with us. Also, thank you to Vermeer for sponsoring today's discussion. Usually before I close out these videos, I'd like to ask, how can people find out more information about the items that we talked about here today?
Of course, we encourage everybody to go to the local dealership. They should be able to just Google Vermeer or go to Vermeer.com.
Wonderful. Thanks, John. Appreciate you taking the time this morning to chat with us.
Thank you. Thanks for having me.
Thank you again to Vermeer Corp and John Cope for taking part in today's Trenchless Technology Videocast. To learn more about what we spoke about, visit Vermeer.com. If you'd like to know more about Trenchless Technology, make sure you visit the Trenchless Technology website at trenchlesstechnology.com. Until next time, take care, everyone.